Hello and welcome back to our third and final segment on linked lists. Last time we left off re-implementing the list or the print method. We implemented the init, the push, and the cleanup methods. So what we want to do today is learn about how we can delete items. So let's jump over to our whiteboard. Oh, my whiteboard's in a funky state. There we go. Okay, so our linked lists are currently looking like this. Let's say we have a linked list of 3. And we have the values 1, 2, and 3 in there. This guy is pointing to here. Second node is pointing to the third node. And this guy is pointing nowhere. Alright. So now, what do we want to do? Now we want to implement the delete function. That's basically the only thing we're really missing from this linked list. We can add items. Sure, it's only at the end right now, but we can add new items to our list, but we can't delete anything yet. So what we want to do is think about the problem first. So when we have a linked list of size 0, we do nothing. That's pretty obvious. If we have a linked list of size 1, we delete the head, and set it to null. When we delete something from a list of size 2, we delete the item, we delete the node, and then we update the previous pointer. And it turns out we do the same thing from here on out. Okay, so how are we actually going to delete items from the list? Well, we can delete by index, or we can delete by matching value. That is, we can say delete 3, and it'll find the item with the value of 3 and delete that one. Or we can say delete the item at index 2, well, index 1, and we could delete this item right here. Because we would still start with 0 as counting, so 0 and 1, this would be our index 1. I'm actually going to go with the approach of deleting a value based on its lookup. So if we wanted to delete, so basically the function we're going to implement is we're going to pass in the value that we want to delete from the list and not the index. Okay, so our signature, our method name is going to look something like this: list delete. And we're going to pass in some value. Okay, so that means there's a couple things we need to care about. One, we need to determine if this value is actually in the list, or if it's not. There's also, so I should write this down. Exists 2 duplicates. What are we going to do about duplicates? Well, for my implementation, I'm actually going to delete the first one found. So first found. So that'll just make it a little simpler. Yeah. And those are really the 2 conditions that we need. One, if it exists in there or not, and duplicates. If it doesn't exist, obviously we'll do nothing. Okay, so let's actually jump over into our IDE. Alright, so I'm going to put this right above list cleanup and put it under list push. So void list delete. We're going to need to pass in our list pointer and our int value. Okay, we'll do our standard list null check, Okay, let's jump back over to our whiteboard. So what are we going to do? We're going to set a current pointer again. So let's get 3 values. Just to whiteboard what we're going to do. Alright, so we're going to need a current pointer again. That's going to point to the first item to begin with. And what we're going to actually need to do is hold on to this value. Because as we move here to check, so I'm going to write current T as our temporary current. We need to check this value, let's call it Y, for equality on the value that we're passing in. Because we're going to actually need to update the previous node's next pointer. So as we delete this block, we're going to need to change this pointer from being pointing to there to now point here. And so if we don't have this pointer right here, we won't be able to get back to this data. Okay. So let's go on over to our list. So let's go ahead and create a new pointer called current, and it's going to point to the head. Okay. So now we're at the start. So our first check is if our head is null. Well, let's just go ahead and do it up here. If list head equals null, then return. Alright, we have an empty list. We don't need to do anything. Okay. So now let's actually check the case where the item that we find is the first item. So if list head, well, let's actually just do it down here in current. So our current is going to be our head. So if current value equals value, then we know we're going to have to delete. Let's jump over here. Then we know that what we've actually found is the head. And so we're going to actually have to update our list.head instead, and point that to here. Okay. So if our current value equals the value, perfect, then we set list.head equal to current next. And this handles the case of if there's only one item in the list and the next pointer is null, because current next will be null. And then we go ahead and delete current. And then we're actually done. So I'm going to return from here right now. Okay, so what I have right here is this is the check. Let me just go ahead and write this. Special case for first item. Okay. Well, let's actually get rid of the return, because I don't want our code to be too spaghetti-like. Alright, so now we have else. So we're not dealing with the special case of the first item. Perfect. So now we're actually going to need another pointer. Well, okay. So now we're in this spot now. Let's draw a new list. So this is all we know. We know that this value did not pass. Or it's not the value that we're passing in. So let's put 1 here. And let's say we're looking for the value of 4. Okay, so 4 is not equal to 1. All right. That's great. So now we're going to store a new, we're going to make a new pointer called prev. And this is going to point to here, and then we're going to move our current over to the next spot. All right, so we're going to create a new pointer, node previous equals current. Okay. Now we're going to loop through all of the nodes. So actually we need to set current equal to current next at this point. Okay, so now we're going to loop through all of the nodes and basically do the same check. So while current does not equal null, check if current value equals val. If it does, we have found our node to delete. If it does not, then we have not found our node. So let's do that code first. If we haven't found it, what we're going to do is we're going to set previous equal to current and current equal to current next. If we have found our code, or found our node, let's look and see what we do. So let's jump over here, back to our whiteboard. Okay, so we've already handled this case. Perfect. So let's handle this case. Let's say 4 is actually here. So our previous is pointing to here. Our current is pointing to here. So we need to set the previous's next pointer equal to the current's next pointer. Okay, so let's go do that. So we have previous next equals current next. So basically we have just jumped across the node that we're deleting. So our node that we're going to delete here, we're now pointing, well, we're going to delete this in a second, and we're setting this pointer, this guy right here, to this value, which would be a pointer pointing to somewhere, but it's null. Okay. So we've updated our pointer. We have no other pointers going anywhere that we need to worry about, so we can go ahead and delete the current node. And now we don't want our loop to continue. So here I'm actually going to do return. So this is some kind of some cryptic code. We'll see if we can't clean it up a little bit here in a sec. But so this should actually go ahead and delete our nodes. So let's go ahead and test it out and see if my function works. Okay. So let's do list, delete, pass in the address of the list, and let's delete 2. Okay, and then we'll print the list again. Oh, we have a bill there. List.head current next. List is a pointer, so I should have used the arrow resolution, not the dot. Build succeeded. Perfect. Alright, so if we run this and we check it over, we see in fact that 1, 2, 3 is our original list, and here's our list after we deleted it. Alright, let's try our other values. So let's update this to be 1. Okay. Jump over here, rerun it. We see that we lost 1, but we have 2 and 3. Perfect. Let's try to delete 3. 3 works too. Wonderful. Now let's try to delete multiple items. Let's delete let's delete 1 here. Let's delete 2 first, and then at the end we will delete 3. Rerun it. Perfect. I'll run it again. We have 1, 2, 3, and now we have no items. Just dandy. So actually, I'm going to go ahead and put that on each line so we can see each step happening individually. We run it. We see we start with the list 1, 2, 3. We delete 2. We get the list 1, 3. We delete 1. We get 3. We delete 3. And we get an empty list. Great. So this code isn't the cleanest, but it does work. We could refactor it a little bit if we wanted to. What could we do to make this a little bit better? I think I'm actually happy with it. It's enough for this video. Let's see. I mean, you can see that we have a little bit of duplicated code with this current next and the current next. This is basically just an iteration loop. I mean, so in theory, well, not in theory, in practicality, we could do this. Our initialization, we're not actually going to do anything for initialization because we're already handling that above. We do current does not equal null. And our next thing we could do is current equals current next, and oops, put previous over here equals current. We could do that, and then we can get rid of this else. And then in here, we could actually use break instead of return. Kind of makes it a little bit less haphazard. So what break does is it stops the execution of the loop that's being executed. It's basically a way to quickly fail this condition. I mean, it doesn't really evaluate this condition, but it tells the loop to stop executing as if this condition had been hit, and it happens immediately. So if there were code below here, they would not actually execute. So we can build this and run it and make sure that actually get the same results. Good, my refactoring didn't actually break any code. And so that's a little bit cleaner, but really it's up to you. If you want to use the for loop, or the while loop or the for loop, either way, totally legit. Okay, so the only one other thing I want to add in this video is our ability to add an item to the beginning of the list. And I want to do that just to re-emphasize here the special casing that we have to do. And to help you just reiterate this pointer address updates that we need to be doing. Okay, so let's say we have the list 1, 2. Now what we want to do is we want to add a node right here. And so this is list head. That's pointing to this guy right here. And we want to add a guy at the beginning. Let's call him 0. So let's go ahead and do that. So we'll create a new function called, we'll call it up here. We'll put it before the push. We'll call this list insert. List pointer int val. So you can see it takes the exact same parameters as push is going to take. Same as delete as well. Let's see here. Let's just copy and paste this. We're going to need that. Our standard if our list is null check. Okay. So we're going to need this basic thing as well. So if we don't have any items in our list, we need to create a new node and add that value. If we do, then instead of traversing the list, what we need to do is just go ahead and create a new node. We'll call it n equals new node. We will set n value equal to val. We will set n next equal to list.head, and we will set list head equal to n. So let's just go over to the whiteboard one more time to illustrate what we're doing here. So we have the list head. It's currently pointing here. Now we want to create a new node, n, and n is going to point to here. And we're going to pass in the value. I just said it was 0. We are going to update this pointer to point to the previous list head. So we're going to point it to here. Then we're going to update list head's pointer to now point to n, to right there. So let's make sure our code's doing that. Next list head, perfect. So let's go ahead and try it out. We will do it here. Actually, I'm just going to copy and paste these 3 lines right down here. And instead of push, we're going to change that to insert. And what we should see is actually 3, 2, 1 be output. Oh, I have a bill there. I did it again. That's a pointer list head. Okay. Let's go over to our build output. We run it, and we'll see our original list. These are our deletions, and then we'll see our insertions. So perfect. So what we've gone through over these last 3 videos is how to actually create a linked list. And these are useful all over the place. Anytime you need to have a large data set of an undeterminate size, linked lists are really great. And depending on how you implement your linked list, you could do fast lookups, you can do fast insertions, fast deletions, and there's even more advanced linked lists that you can create that actually have 2 pointers. So let's say our node is currently looking like this, right? There's a value and our next pointer. Well, there's this thing called a double linked list, which actually you should try to implement one as a user exercise. So this is a value, this is the next pointer, and this is a previous pointer. And so this allows you to do a little bit quicker deletions and insertions. So let's say you want to delete by index, and you wanted to delete the last item in the list. Well, in our implementation, we have to walk the entire list. Well, if you have these previous pointers, you could, in fact, jump to this last one because your list could have a tail pointer and point to here, or you could have a pointer here that points back, and it could be a circular linked list where you could just kind of continuously walk through this all the time. If you had that previous pointer, you'd be able to get to that last item really fast. But really what we've done, we've learned how to create a data type. We've learned how to actually apply some of the concepts that we were learning to create something that's usable and actually get some real code running. And I hope you guys learned some things. I learned a little bit more about pointers and really kind of understood what's going on. I know if you look back at some of these pictures, it looks like there's all these arrow messes, but yeah, hopefully that just really sinks in and that you'll be able to pick that up. And actually, I challenge you to try to write this. If you have problems, jump over to the C++ forums, and I'll be sure to help you guys out. And maybe if this is super confusing, I'll do a follow-up video on this data type. But really, I wanted to do the linked list like this because this is actually a good stepping stone and boiler kind of plate code of how C style coding works, and then we'll be able to jump into our next topic really well with this example. So with that, thanks.